Alright, welcome to the whiteboard, and today we're looking at fractions. So fractions look like this: a number with a line and another number. So could also have this and this, and these all mean divide by. So the reason we write them like this is that none of these give nice numbers. So what do I mean by nice? 8 over 2 as a fraction. 8 with a line and 2 means 8 divided by 2. That's 4. 4 is a nice number. I can just write 4. 10 over 2 is 5. Nice number. 7 over 2. Well, let's write our 2 times table. 2, 4, 6, 8. There's no 7. So you can't get 7 divided by 2 and it be a whole number. So this is what I times 2 by to get each of these numbers. There's no nice number that you times by 2 to get 7. If you want to know what this actually is, it's 3.5. That might mean nothing to you. That's why we write it as a fraction. Because if I had a rod of length 7 meters, say, or you could imagine this was like a bus and it's 7 meters long, I could cut down the middle of that bus and I'd have 2 halves like this, and they would have a length. So even though I can't divide 7 by 2 to get a nice number, I can get a number, and the number I get is 7 divided by 2. So I'm just representing a number that would be weird. 1 over 3 is even worse. 1 over 3 looks like this. And you actually carry on writing 3's forever. So not a nice number. We'll just write 1 over 3. So division, again, is just cutting things up into pieces. So if I cut my bus into 3 equal pieces and it started off as being a 7 meter long bus, then each piece would be 7 over 3 meters long. So 7 divided by 3 is 7 divided by 3. Who'd have thought? So how do we add fractions? Well, we're actually going to have to do this twice. So 7 over 3, add 4 over 3. We actually, if the bottom number is the same, which is called this lovely word, denominator. Don't know why, but if those numbers are the same, then we can just add the top numbers to get the answer. So this would be 7 over 4, 7 add 4, and then we divide that by the denominator, which was 3. So we get that that is equal to 11 divided by 3. So 7 divided by 3, add 4 divided by 3 is 11 divided by 3. And the denominator, the bottom number, stays the same. We can't do this for numbers that are different. We have to do something different. So here, the bottom numbers are not the same, so we can't add them the way we did up here. Now again, the entire time these are just numbers. I'll also add something else. So because of that, 7 divided by 3, we could also write it as 3 divided by 3, add 4 divided by 3. Because 3 add 4 is 7. But 3 divided by 3 is 1. And then we could also write 4 divided by 3 as 3 divided by 3, add 1 divided by 3. Because 3 add 1 is 4. But then you'll notice we've got 3 divided by 3 again, and 3 divided by 3 is just 1. So this equals 1, add 1 over 3. So we can write 7 divided by 3 as 2, add 1 divided by 3. And this is a mixed number. So a lot of times we'll want to write fractions like that because you're kind of saying, if I divide 7 by 3, the answer I get is 2 and then this extra 1/3. So 7 divided by 3, we've just shown, is equal to 2. Add this annoying fraction that isn't a nice number, and we call that the remainder when we divide. So you take away the number divided by itself, because that's just 1, so every time that is a whole number, a nice number, and you do that until you can't, and the amount left over is called the remainder. So that's something we can get from our fractions. So we have just worked out a way to write 7 divided by 3 in a different way. So we've kind of got closer to what it is, and that's just useful because we might be able to use this fraction later to get another nice number in some other thing. So that's why we do that. So next up is multiplication. Multiplication, it doesn't really matter what numbers we have. So if I have 2 different numbers, the rule is the same. You multiply the top numbers and put it at the top of the new fraction. Then you put your line. Then you put the bottom numbers multiplied together at the bottom. So we get that 1 divided by 3 times 2 divided by 4 is 2 divided by 12, because that's the result of these multiplications. So an interesting thing from this is if I multiply a fraction by a fraction that's the same number on the top and bottom, and also I'll note here the top is called the numerator, so the bottom was the denominator, and the top is called the numerator, but I'll just call them the top and bottom because I hate these words and they're just confusing. This is 3 divided by 3, and that is equal to 1. So if we actually times a fraction by a fraction that's the same on the top and bottom, we're actually timesing by 1, which means the number is the same. But if we use this rule up here for how you multiply fractions, you'll see we get this, which is 3 divided by 9. So what I've actually done here is 1/3 times 1, which means it's the same number, is 3 over 9. These two are the same number, even though they're made up of different numbers. And we can actually use this to do a process called simplifying. And essentially, all it is you want your numbers to be as small as possible. So if I had 3 divided by 9, here I showed you that that is the same as 1/3. Because if we times 1/3 by 1, written as 3 over 3, using our fraction rule, we arrived at these two being equal. So if I started off with 3 divided by 9, to make any addition or multiplication easier later on, I would write that as 1/3. And if you've noticed, that is because I can divide 3 by 3 and I can divide 9 by 3. So if you can divide the top and the bottom by the same number, then if you do that, you'll get the same fraction, just written with smaller numbers, and that makes it easier to use again in some later thing, like if you're adding 2 numbers together. So if you can divide the numbers in a fraction by the same number, so in this example it's 3, then do that and you have simplified it to a lower one. So another example, if I had 4 divided by 6, you may notice 6 can be divided by 2 and 4 can be divided by 2. So if I do that, this equals 2 divided by 3. And we can see that because if we times it by 2 over 2, and again, this is just 1 because it's a number divided by itself, so we're not changing it, then we get 4 and 6, so they are the same. So we have now simplified 4 over 6 because I can't find any number that divides 3, 2. So I'll actually do dividing by fractions as well. Now the trick with division is dividing is actually very similar to multiplying, and this is very true with fractions. So it seems weird that you divide by a number that's made of a number divided by another number, but sometimes you do in maths. That's just something you're going to have to do, because if I do 5 divided by 2, well, 4 divided by 2 equals 2, so that's the same as 5 divided by 4 divided by 2. So because this is just a number, we can divide by it, and we're just writing it like this so that it's easier to write. So obviously writing 2 as 4 divided by 2 is not easier, but that was just to show, because in the examples where you'd actually do this, it would be easier. So to divide by a fraction, so let's do 5 divided by 2 divided by the opposite, 2 divided by 5. Well, what you actually do is you flip the second fraction that you're dividing by so that the bottom number, the denominator, is on top and the top number is on the bottom, and then you change that divide to a multiply. So 5 divided by 2 divided by 2 divided by 5 is the same as 5 divided by 2 times 5 divided by 2. And if we do that using our rule, we multiply the top numbers and divide that by multiplying the bottom numbers. So we get 25 divided by 4. So 5 divided by 2 divided by 2 divided by 5 is 25 divided by 4. A consequence of our division rules is that if we have a fraction like 1 divided by 2, and that is divided by another fraction, so again this line just is a divide symbol, but the dots are the numbers we are using. So 1 divided by 2 divided by 3 divided by 4. What you do in this case is, like we just saw, what actually happened was the bottom number from the number you're dividing by, the fraction here, goes to the top and you multiply by it. So in this case, because we've got 3 divided by 4 at the bottom, that means we take this 4 and we multiply this 1/2 by it, which means we multiply the 1 by it. So that'll equal 4 divided by 2, and then we keep our line in the same place and we do that divided by 3. And then what you do with the top number is you times it by the bottom number from the top of the entire thing, right? So what that means in that case is that you take the 3 and you multiply it by 2. And that's the new bottom number in your fraction. So that'll go there. So again, we took our bottom number at the very bottom, which is the 4, and we multiply the 1 at the top by it, and then we multiply the 2 middle numbers, and they become the number at the bottom. So instead of having this divide by 3, it'll be 4 over 2 times 3, and that'll equal 4 divided by 6. This is what you get when you divide two fractions by each other. So two fractions, it's like this. So the circles will multiply by each other and the squares will multiply by each other, and what we end up with is a fraction that looks like that. That is the rule. So what if we wanted to add two numbers which don't have the same bottom number? So here I've got 1 divided by 3 and 4 divided by 5. Well, if you remember in the multiplication bit, we showed that as long as you multiply the top and bottom by the same number, or divide them by the same number, the answer will be the same fraction, just written differently. So how we got 1 divided by 3 is the same as 3 divided by 9. So what we can use that, as well as if the bottom numbers were the same, we could add these two. So we need bottom numbers. We need to change this 3 and this 5 by multiplying them by some number to make them the same number. And we just have to multiply the top numbers by the same amount to keep both of them the same. So the easiest way to do this is to times 1 by the bottom number, the denominator, from the other one. And what I mean by that is, like, I'll get my 1/3, and if I times it by 5 divided by 5, because 5 is the bottom number here, then I will get 1 times 5 divided by 3 times 5, and that'll be 5 divided by 15. So what I've got here is that 1 divided by 3 is the same as 5 divided by 15. Then if I do the same with the second number, which is 4 divided by 5, if I take the bottom number from the other one, which is 1 divided by 3, so it's a 3, then I'll do the same of getting 4 divided by 5 and timesing it by 3 divided by 3. So I've got the bottom number, done it over itself, because then I'm multiplying by 1, so I get the same number, but it's written differently using our multiplication rule here, where we multiply the top numbers and then we divide them by the multiply of the bottom numbers. We get that that equals 12 divided by 15. And what you'll notice is that we have 15 on the bottom of the second one and 15 on the bottom of the first one. So we've now written these numbers in a way where the bottom numbers, the denominators, are the same. So that means we can add them together easily using our rule of adding. So what we've got here, well, I'll write it out fully, is that 1/3 add 4 divided by 5 is the same as 5 divided by 15 add 12 divided by 15, and we just add the top numbers. 12 add 5 is 17 divided by 15. And we can use our mixed numbers thing because 17 is bigger than 15. So 17 divided by 15 equals 15 over 15. And then add some extra bit, and the extra bit in this case is 2, because 15 add 2 is 17. And the reason we did that is that 15 divided by 15 is just 1. So we can write our answer as 1 add 2 over 15. And a lot of times in the maths exams and things, they'll actually just write this as 1 with 2 divided by 15 as a fraction next to it and not put the add. So that's how we add together fractions with different numbers. So the rule is you have your first number and your second number. So you times your first number by the second number the second bottom number over itself, and then you times this second bit here by the bottom of the first one, divided by itself, because that's effectively timesing by 1, which means you get the same number, and then you add those two together because you'll end up with the same bottom number. Like that, which will mean you can do the sum, and then if the top number is bigger than the bottom number, which we call top heavy, then you can write it as a sum of normal numbers, sort of nice numbers, add some extra, so 6 add 1 in this case is 7, so we can write it like this, and then 6 divided by 6 is just 1, so that equals 1, and 1 divided by 6 remaining, so the remainder is 1 divided by 6 when we divide 7 by 6. So go through, make sure you're comfortable with everything, and then I'll just give some practice questions. So question 1. On basic addition, what is 2 divided by 5 add 3 divided by 5? Number 2. This is a mixed numbers question. What is 2 divided by 3 add 5 divided by 3? Question 3. What's 2 divided by 3 times 1 divided by 3? Question 4. What is 2 divided by 3 add 1 divided by 2? And remember, this is using multiplication to add two different numbers. So make sure you remember the rule. So the hint is look at the bottom numbers and remember how that works. Question 5, just so you can relate addition to subtraction. What is 2 divided by 3 minus 4 divided by 3? This requires you to realize that if I have a number bigger than another number, like this, 2 minus 4, then what you actually do is, well, I go 2 steps backwards, I'd get to 0. But then we've got to take away another 2 because the number is 4. So for any number that ends up like this, where it's 0 minus a number, we just write that as minus that number. So 2 minus 4 is minus 2. And that also means like 3 minus 6 would be the same as, well, if we took 3 away, so we're going from our 6, because that means you go 6 steps backwards, essentially. So the 3 will go to 2, go to 1, go to 0, if we went 3 steps backwards. But then we've got another 3 left from our 6, so that's 0 minus 3, so that means 3 minus 6 is minus 3. So that's what we're using for this bit, taking away a number. And then you can also use this to do 2 divided by 5 minus 1 divided by 4. So you can just use the multiplication rule like you did with the addition, but then you're subtracting instead of adding. the second number. As a lovely challenge question as well. What would you do if you had 3 numbers? So we're going to do 1 divided by 3, add 1 divided by 4, add 1 divided by 2. So hint is multiply with both other numbers. So go off and do them, and then I'll go through the answers. Okay, so the answers, I'll just draw a box here so I can draw the answers on the other side for question 1. Well, we said when the bottom numbers are the same, the denominators, you can just add the top 2 numbers when you're adding them. So that'll just equal 2 add 3 divided by 5, which is 5 divided by 5, and a number divided by itself is just 1. So the answer to question 1 is 1. For question 2, we got the same thing. 2 over 3, add 5 over 3, so we can just add the top numbers, the numerators, because the bottom numbers, the denominators, are the same. So 2 add 5 is 7, then divided by 3. But we saw earlier that 7 divided by 3, we can write that as 3 divided by 3, add 4 divided by 3, and that's just 1. But then 4 divided by 3 is also 3 divided by 3, add 1 divided by 3. So then we've got add another 1 from this 3 divided by 3. Again, so that means this is actually 2 add 1 divided by 3, and we could also write that as 2 and a third. So our remainder is 1/3 when we divide 7 by 3. So this 2 was just because the 3 divided by 3 add the other 3 divided by 3 is 1 add 1, which is 2. So for question 3, 2 over 3 times 1 over 3, while the rule for multiplying is you times the top numbers and pull it at the top, so that's our new numerator. And then our denominator is the 2 bottom numbers multiplied together, so 3 times 3 in this case, and that equals 2 divided by 9. And because 2 is smaller than 9, we can't make that into a mixed number. That is just how it ends up. Question 4, 2 over 3 add 1 divided by 2. Well, the first number we are timesing by 2 divided by 2 because that's the bottom of the second number. And the brackets just mean do this first before you do the next bit, which would be adding, right? So that's what brackets mean when we put them in an equation. And then the second number we need to multiply by 3 divided by 3 because that's the bottom number in the first fraction. So we get half times 3 over 3. Again, the brackets just mean do the bit inside the bracket first. So that equals 2 times 2 over 3 times 2, add. I'm pretty sure this might have been the example I did, mightn't it? So top numbers multiplied, bottom numbers multiplied, and we do that for both of them. Because again, these are the same numbers, we multiply by 1, and that will give us 4 over 6, add 3, divide by 6, and now because the bottom number is the same, we can just add the top. Numerators added together is 4 add 3, which is 7, divided by 6. We just keep the bottom number the same. The top number is bigger than the bottom number, so we can write this as 6 divided by 6, which is 1, and our leftover to make the 7 divided by 6 is 1, because 6 add 1 is 7. That is equal to 1 and 1/6. So our remainder, if we divided 7 by 6, is 1/6. Question 5, 2 over 3 minus 4 over 3. So again, this was challenging because I introduced the thing of minus numbers, where if you go below 0 when you're subtracting a number, you write minus and then whatever number you end up at. These are the same bottom number, and because subtraction is just addition but going backwards, instead of going one step forwards that many times, you're going backwards that many times. So we've got 2 minus 4 divided by 3, and that means we get 2. We go one step backwards to 1, one step backwards to 0, one step backwards to 0 minus 1, and then our fourth and final step, because we're subtracting 4, to 0 minus 2, and then divided by 3. And then, like I said, we just write this 0 minus 2 as minus 2 divided by 3. So that is called a negative number, and it's just like if you had a number line, you have 0 here, If I went 1 step in that direction, I'm at 1. If I went 2 steps, I'm at 2. But if I decide to go the other direction, we'll just say that it's -1 because I took minus a step. So like I was walking backwards, and then it could take -2 steps. And I could do that for any number. So I could take -7 steps if I walked 7 steps backwards. Question 6. 2 divided by 5 minus 1 divided by 4. Well, the bottom number is 4 for the second one, so we times the first one by 4 over 4. And the bottom number is 5 in the first one, so we times the second number by 5 over 5. And then we subtract the second number, which is 1/4, times 5 over 5, because that was the denominator in the first number. So we get 2 times 4 over 5 times 4 minus 1 times 5 over 4 times 5. And that is 8 over 20 minus 5 over 20. So because it's the same number on the bottom, we can just pay attention to the top. 8 minus 5 over 20, which equals 3 divided by 20. So for question 7, the challenge question, I still encourage you to try and do this yourself now you've seen the other ones, but what I said is you multiply by both the other things. So for this 1/3, I'm saying to get the same number at the bottom, you want to use this 4 and the 2. And what I mean by that is, we take that 1/3, we times it by 4 over 4, and we times it by 2 over 2. So now for the 1/4, we get that 1/4, and the bottom numbers of the other ones are 2 and 3. So what we do there is we times it by 2 over 2, and then we times it by 3 over 3. Because these are both 1, so we still end up with the same number. Like the fraction is the same number in the end, but it's just got a different number on top and the bottom, so we can add it easier. Finally, the 1/2, bottom number of the other ones are 4 and 3. So we times it by 4 over 4 and 3 over 3. Hope this has cleared up why, but more importantly how you use fractions in maths. If any of it's unclear, you can go through or ask me. If any of it's unclear, just go through the video again or look for other videos. There's loads of good ones out there. I've been the Yboard, and I'll see you in the next video.